Alright, this is our last video on solutions, and we're talking about diluting solutions. So recall that a concentrated solution, just a couple definitions to remember. A concentrated solution has a large amount of solute dissolved, which means they also have a high concentration. Okay, or it could be that it's got a very small volume, which would lead to a high concentration. But it's got a large amount of solute for the amount of solvent there is. A less concentrated solution can be prepared by diluting the stock solution. Okay, so diluting, I often talk about this like watering down. So if you've had a little sibling that when your parents go to give them a drink, if it's like tea or juice or something like that, they might dilute it. They just pour a little bit of water in so that there's less of the, whatever the juice is or whatever the drink is that they're drinking, there's less in there per unit of volume than there was before because you watered it down, you added a little more solvent. That's what diluting a stock solution is, or diluting a solution, any solution. How do we do this? We do this by adding more solvent. Often water, but just adding more of the solvent, which is usually water. This changes the volume. So it increases the volume without changing the amount of solute. So here's our question. If I just add solvent, will I still have the same number of moles of solute in the new solution? Well, yes. But it now has a greater volume. Remember, the moles of solute in the stock solution equal moles of solute after the dilution. That's an important key concept to make sense of the molarity equation. Also, keep in mind we can do the inverse of this, where instead of diluting it by pouring more water in, we could evaporate the water off. So we could boil it and get some of the water out. That would be reducing the volume, which would increase the concentration. So you can do the inverse. You could boil water off. All right, since the molarity, our molarity equation is moles of solute over volume of solution in liters. That's our equation. Then moles of solute is molarity times volume of solution. You could write it like this: N equals M times V. So the number of moles is M times V. Remember, the number of moles didn't change. When I pour more water in, the number of moles doesn't change, so this has to stay constant. So in other words, my original molarity multiplied by my original volume would be the number of moles. It will be equal to the final molarity multiplied by the final volume. This is a useful equation we'll use called the dilution equation. M1V1 equals M2V2. Very useful equation. Let's look at a couple examples. What volume of a 3 molar Ki stock solution, so this is V1, M1, would you use to make 0.300 liters, so I'm trying to make it, that's my second volume, V2, of a 1.25 molar Ki solution. This is M2. And then it asks how much water is needed to dilute the stock solution. We'll get to that in a little bit. Let's first find V1. Okay. So I've got M1, V1 equals M2, V2. That's our equation. M1, V1 equals M2, V2. So M1 is 3.00 molar. V1 is unknown, and that's going to be in liters. M2 is 1.25 molar, and then V2 is 0.300 liters. Now let's set up our equation. M1 V1 equals M2 V2. 3.00 times V1 equals 1.25 times 0.300. Now, to solve for V1, I would just divide by 3 on both sides. Okay, we can go ahead and put that in a calculator and solve for it. You may be able to do that in your head, possibly, but if not, you do 1.25 times 0.3 divided by 3. You get 0.125. So V1 is 0.125 liters. There's our volume. Okay, how much water was needed to dilute the stock solution? Well, we have our final volume, we have our initial volume. Remember, the only thing that changed is the amount of solvent, so pouring the water in. So what that means is that the volume of water that was added is going to equal V2 minus V1. So you have 0.300 minus 0.125. So I think you get 0.175. Let's check that. 0.175. Okay. Look at example 2. And if you get the hang of it, try example 2 on your own. You may not need to watch this, just check the answer at the end. How many milliliters of a 5 molar H2SO4 stock solution, okay, so that's V1, M1, would you need to prepare 100 milliliters, that's V2, of 0.25 molar H2SO4, that's M2. Okay, again, M1, V1, M2, V2. Now keep in mind, since this equation is involving just a ratio, a multiplying ratio, we don't actually have to convert to liters to use this equation. With the molarity equation, we do have to convert to liters, but with this one, it's okay to leave it in milliliters. If you feel more comfortable, you can always convert to liters and you'll be fine. But in this case, since I'm looking for milliliters, I'm just going to say milliliters, and I'm going to leave, you just got to make sure that your units match. So I have 5.0 molar, I have 0.25 molar, and then the new solution is 100 milliliters. Let's just plug in our numbers. M1 V1 equals M2 V2. 5.0 times V1 equals 0.25 times 100. So 0.25 times 100 is going to be just 25. Divided by 5 will be 5. Just to justify that though. V1 equals 0.25 times 100, again 25, divided by 5 is 5.0 milliliters. That would be V1. And again, if I want to find the volume of water, how much water is added in the process, the volume of H2O added is going to equal V2 minus V1, which is 100.0 minus 5.0. our answer comes to be 95.0 milliliters.